All right, let's look at our special angles. Now, special angles can be taught in triangles, or it can be taught as this part of the Cartesian. I prefer to do the Cartesian. It's just easier for me to explain and for you to remember during an exam. But use what works for you. I'm going to use the Cartesian, okay? So on this one, what I need you to know is that you have this Cartesian plane, which you can use your left hand for. If you spray out your fingers, your left hand, if you splay out your fingers, if this is your pinky that points up and this is your thumb that points to the right, then in between you have three fingers, the first, the second, and the third, right? This is your pointing, middle, and ring finger. If you have this scenario, then you are able to identify different ratios or special angles. So special angles are questions that we answer without using a calculator. And basically you use this diagram to remember what each one angle is equal to, right? So let's go over this quickly. How do you fill in the values? First of all, you need to remember that going from the bottom, you're going to go with 30, 45, 60, and 90 degrees. Those you just simply remember. Okay. Once you've got this diagram sort of on paper, now you can fill in the values. I want you to start here at the top. So start here at 90 degrees, and I want you to start with, over here, x is 0, right? 0, 1, 2, 3, 2. That is the first set of coordinates that I want you to put down. Once you have gone down, I'd like you to go back up, starting next to the x. So 0, 1, 2, 3, and 2. Close. Okay, before we do brackets, the third thing I want you to do is I want you to put square root signs in the middles. So this 3, 2, 2, 3. Those four items are going to get square root signs. These are the coordinates that I want you to be able to produce from memory every time you do this. So again, you are going to draw the shape. You're going to start at 90 degrees. So your vertical line, you're going to go 0 going down. So start with your x coordinate, 0, 1, 2, 3, 2. And then next to the 2 by the x, y coordinates going up, 0, 1, 2, 3, 2. Square root, the middle 4, 3, 2, 2, 3 are all square rooted. In this diagram, what does this mean? It means that the distance from here to here is 2, which means that the r, the radius, is 2. R equals 2, R equals 2, R equals 2, and R equals 2. From here to here are 2 units. So this here is the blueprint that you are going to put on paper within 15 seconds. You need to be able to produce this from memory, and you need to be able to use this so that you can use our definitions, y over r, x over r, y over x. You use these values in order to answer the questions. There's a second way of doing this. So the one that I did right now was just like straight to the point, no further calculations needed. But there's another way where you can do it needing calculations. So if you did the diagram, I'm going to show you how to do it in a few seconds. So you're going to draw your L shape, then you're going to draw 3 branches, and then you can, if you want to, you can connect it if you want to. I don't mind that. Now you are going to input your coordinates, and your coordinates are going to start at the top. So at the top, you're going to give me 0, 1, 2, 3, 2. Hold on. No, I'm saying we're doing it different, right? We're going to do it with more calculations. So we are actually going to start with 0, 1, 2, 3, 4. And then on the right hand side, we are going to go 0, 1, 2, 3, 4. Now you're going to close all of your brackets. That's a 1. Close your brackets. And what's missing now is your square root signs. So on this one, what has to happen is you square root everything. And once you square root everything, you simplify. The result of simplifying is that. So after you simplify everything, you will get the original one that I showed you, because the square root of 0 is 0, square root of 4 is 2, square root of 1 is 1, square root of 3 remains the same, square root of 2 remains the same, and so forth. So that is more or less how you produce special angles before you use them.